Hello everyone, let's go ahead and take a look at a different type of sequence. Now before we discuss the arithmetic sequence, which is based upon a common difference, in this case we're going to take a look at something that looks like this. Say for example we have 2, 6, 18, 54, etc., etc. Now if we go ahead and take a look at the patterns of words, we would start off with 2 and then multiply by 3 to find the subsequent terms. So if I go 2 times it by 3, that's 6, 6 times it by 3 is 18, 18 times it by 3, 54, etc., etc. So what I have then is now I've defined basically what a geometric sequence is. Okay? The sequence u sub n is geometric if and only if r is going to be equal to u sub n plus 1 divided by u sub n. For all n is an element of z. Now we're going to go ahead and call R the common ratio. Okay? And we're also going to go ahead and come up with an algebraic formula for this particular geometric sequence by using our initial statement, which states that u sub n is equal to u sub 1 times it by r to the n minus 1 power. Now, in order for us to actually go from the words to the algebraic formula, in other words, if we wanted to go ahead and change this description or that sequence, which is geometric, and change it into its formula, we need to know what u sub 1 is and we need to know what r is. So, if we go ahead and start off with this particular situation here, and we want to change this into its formula form, then we know that u sub 1 is going to be equal to 2 because that's the first term. And if I was to go ahead and look for the common ratio, okay, the common ratio in this case is going to be 3. Because if I take 54 divided by 18, or if I take 18 divided by 6, or if I take 6 divided by 2, all of those will come up with a constant 3, which is going to be called the common ratio between successive terms. So what I can do then is I can actually go ahead and change this particular sequence into the formula form, which is u sub n is equal to 2 times it by 3 to the n minus 1. So long as you know what u sub 1 is, and r, and you know that it's a geometric sequence, you can always go ahead and use this initial statement to find the algebraic formula for that sequence. Now, let's go ahead and take a look at a different example, a little bit more challenging example, I think, as well. It says find u sub n, or in other words, find the sequence, if u sub 3 is equal to 8 and u sub 6 is equal to 1. Now, we're going to assume at this point, being that we're working with geometric sequences, that this is indeed a geometric sequence. Now, again, in order to find out what u sub n is, we just need to remember that we have to find out what u sub 1 is and r is. And from this information here, it's hard to tell exactly where we're going to come up with that information. Now, the thing though, is that we know that u sub n is equal to u sub 1 times it by r to the n minus 1 is going to apply to this particular geometric sequence. So I'm going to use that as my initial statement. This is what I'm going to start off with. And what I'm going to do then is I'm going to say, well, u sub 3 then, if I put in the n is equal to 3, should be equal to u sub 1 times it by r to the 3 minus 1, and u sub 3, of course, in this case is 8. And that should be equal to u sub 1 times it by r squared. Now, I'm also going to be able to do the same thing with u sub 6 is equal to 1. So u sub 6 is going to be equal to u sub 1 r to the 6 minus 1, and u sub 6 again is equal to 1 is equal to u sub 1 r to the 5th. So notice that what I have here is I have this equation here and this equation based upon my initial statement and what the question is giving me as initial information. Now, what I have here is I have two equations and two unknowns. Two equations, two unknowns. Here's one equation, two equations. The unknowns is u sub 1 and r. So what that means then is that I now have a system of equations, and being that the number of variables and the number of equations is the same, then I can go ahead and solve the system of equations, and in this case I'm going to use the substitution method. So what I'm going to do is I'm going to change this form here to say 1 is equal to u sub 1 r squared times by r to the 3rd, because of course that's what that's equal to if we go ahead and simplify. But the reason why I'm changing it into this form here is because u sub 1 r squared is 8. So if I substitute that here, I come up with 1 is equal to 8r cubed. If I divide both sides by 8, I get r cubed is equal to 1/8. If I take both sides to the 1/3 power, raise both sides to the 1/3 power, I get r is equal to 1/2. Now, I need to also remember, find out what u sub 1 is. I got r, I need to find out what u sub 1 is. So if I just go back into either one of these two formulas, I got 8 is equal to u sub 1 times it by the quantity 1/2, because that's what r is, raised to the second power. That means that 8 is equal to u sub 1 times it by 1/4. I multiply both sides by 4. I got 32 is equal to u sub 1. There you go. I found out what u sub 1 is and what r is. Now I can go ahead and determine what my general sequence term is. And that's just going to be u sub n is going to be equal to 32 times it by the quantity 1/2 raised to the n minus 1 power. Now, of course, the best thing for us to do is to go ahead and just check to make sure that that's correct. If I go ahead and substitute the value of 3 for n into this particular formula that we found or generated, then I come up with 32 times it by 1/2 raised to the 3 minus 1 power, which is the same thing as raised to the second power. So that's 32 times it by 1/4, which is equal to 8, which is consistent with the original information that was given to us. If I check u sub 6, that's going to be 32 times it by 1/2 raised to the 6 minus 1 power. That's 1/2 raised to the 5th power, which is 1 over 32. 32 times 1 over 32 is equal to 1. So I know that I've actually found the correct u sub n for this particular geometric series, geometric sequences. So again, let's go ahead and wrap up. If we can go ahead and find a common ratio, which is given by this, for all n is an element of z, then I can go ahead and call that sequence geometric. And if that sequence is geometric, so long as I know what u sub 1 is and r is, I can go ahead and use this initial statement to go ahead and generate the algebraic formula for that geometric sequence. Okay, so we'll go ahead and take a look at some other examples and field any questions that you might have about geometric sequences in class the next time that we meet. See you next time. Bye-bye.